On the morning of October 15, 1944, aboard the Japanese submarine I-368, Lieutenant Commander Yukio raised his periscope above the waters of Ulithi Atoll. What he saw would shatter all assumptions held by the Imperial Japanese Navy regarding American naval capabilities. Through the lens, he observed not just warships anchored in the bay, but something truly perplexing: huge floating structures that seemed to be full-fledged machine shops operating at sea. The USS Franklin, an aircraft carrier, was nestled within one of these colossal vessels, with its flight deck alive with workers and equipment. Steam rose from welding operations, and cranes moved heavy machinery. The Americans had brought their industrial base directly to the front lines. In his coded transmission that evening, Soto sent a report that would send shockwaves through the Japanese Naval Command. Enemy possesses floating factories capable of major carrier reconstruction. Ship repair capabilities exceed all previous intelligence estimates. What Lieutenant Commander Soto had witnessed were floating machine shops, specialized vessels representing American industrial ingenuity at its boldest. These weren't just repair ships. They were complete manufacturing plants, able to rebuild entire aircraft carriers from the waterline up while operating far from any permanent base. 3 months before the attack on Pearl Harbor, in the conference rooms of the Japanese Naval General Staff in Tokyo, Admiral Osami Nagono had presented calculations that appeared irrefutable. American aircraft carriers were the primary threat to Japanese expansion, but they had a critical vulnerability: their complexity. The Yorktown-class carriers consisted of over 2 million individual parts. Their steam turbines required highly specialized metallurgy, and their flight deck elevators demanded precision engineering that could only be found in major shipyards. Commander Minagenda, the architect behind the Pearl Harbor attack plan, had studied American carrier construction in great detail. His intelligence reports outlined every major American naval facility on the Pacific coast. The Mare Island Naval Shipyard in California could handle repairs on 2 carriers simultaneously, while the Puget Sound Naval Shipyard in Washington could accommodate 3. Pearl Harbor, the closest major repair facility to the combat zone, could manage emergency repairs on 4 carriers at most. The calculations appeared to be in Japan's favor. If kamikaze attacks in naval aviation could disable 6 to 8 American carriers in the first year of the war, the resulting repair bottlenecks would keep American naval aviation out of action for months. These carriers would have to steam 3,000 miles back to the West Coast for repairs, taking them out of combat for 4 to 6 months per ship. The vast distances of the Pacific seemed to work in Japan's favor. Even Admiral Isoroku Yamamoto, despite his reservations about war with the United States, supported these assessments. His chief of staff, Rear Admiral Rinosuke Kozaka, presented charts that demonstrated the limitations of American industrial capacity. While the U.S. could build carriers faster than Japan, their operations relied not just on hulls and engines, but on specialized machine shops, precision tooling, and skilled technicians available only in major naval yards. They had not anticipated that the Americans would simply build mobile naval yards and deploy them directly into the combat zone. The concept of floating machine shops arose from the American realization that modern naval warfare would be fought over such vast distances that traditional repair facilities would no longer be sufficient. In 1941, the Bureau of Ships began exploring the possibility of mobile industrial units. Captain Samuel Robinson, head of the Ship Design Division, proposed an idea never before considered: ships designed not to fight, but to rebuild those that did. The specifications for these ships seemed impossible. They would need to manufacture everything from aircraft engines to gun barrels. Their foundries had to be capable of casting propeller shafts, and their machine shops needed to work with tolerances measured in thousandths of an inch. The electrical systems had to be capable of rewiring an entire aircraft carrier. Most critically, they needed to operate independently for months at a time, without resupply from the U.S. industrial base. The first floating machine shop, USS Vulcan, was commissioned in June 1941 and represented one of the most ambitious engineering feats of the war. At 625 feet long and displacing 16,200 tons, Vulcan carried more machine tools than some entire factories. Her workshops contained lathes capable of turning shafts 40 feet long, presses powerful enough to forge anchor chains, and electrical shops that could rewind the motors that powered the massive carrier elevators. Vulcan's complement of 1,400 men included master machinists, electrical engineers, metallurgists, and other specialists in the trades necessary for naval construction. These were not ordinary sailors. They were industrial craftsmen who had honed their skills in Detroit's automotive factories, Pittsburgh's steel mills, and the great shipbuilding centers of the United States. Commander James Morrison, Vulcan's first commanding officer, summed up a mission in his post-war memoir. We were to be Detroit and Pittsburgh made mobile, capable of rebuilding anything. The Navy could float. This was the ambition, but the reality would exceed even these bold goals. The Japanese first encountered the capabilities of floating machine shops during the Guadalcanal campaign, although they initially failed to understand what they were witnessing. On October 13, 1942, Japanese battleships Kongo and Haruna bombarded Henderson Field, seemingly causing devastating damage to American naval aviation. Reconnaissance flights confirmed the destruction of numerous aircraft and facilities. Yet, just 3 days later, Japanese pilots reported seeing massive American air activity from the same base. Intelligence officers dismissed these reports as pilot error or wishful thinking. How could the Americans have rebuilt their air capabilities so swiftly? The answer lay offshore, where the USS Vulcan was operating alongside the destroyer-tender USS Whitney. Vulcan's machine shops had worked around the clock for 72 hours, manufacturing replacement parts of the damaged aircraft. Her foundries had cast new engine blocks. Her electrical shops rewound burnt-out motors. Her precision machinists fabricated control surfaces and landing gear. What would have taken weeks at a fixed facility, Vulcan accomplished in mere days while anchored in contested waters. Captain Tadashi Nakajima, commanding the Japanese carrier Shokaku, first experienced American floating machine shop capabilities firsthand during the Battle of the Santa Cruz Islands on October 26, 1942. His aircraft had successfully damaged the carrier USS Enterprise with multiple bomb hits, seemingly delivering mission-killing damage to her flight deck and elevator systems. Japanese intelligence estimated a minimum of 6 months for Enterprise to return to operational status, if she survived the journey back to Pearl Harbor. Standard doctrine suggested that elevator damage required dry dock facilities and specialized lifting equipment, available only at major naval bases. The Japanese had essentially written Enterprise off as eliminated from the war. Yet, just 28 days later, Enterprise reappeared in combat during the Battle of Guadalcanal. Her elevators functioned perfectly, and her flight deck showed no signs of previous damage. Nakajima's post-war interrogation revealed his confusion. We confirmed severe structural damage to Enterprise. Our intelligence indicated an impossible repair timeline. Yet, she returned to battle stronger than before the attack. The transformation had taken place at Naumea, where the USS Vulcan had essentially performed a complete reconstruction of the Enterprise's damaged sections. Vulcan's crew fabricated entirely new elevator machinery, replaced the damaged flight deck sections, and upgraded systems beyond their original specifications. The repairs were made not in a permanent dry dock, but in open anchorage, while Vulcan's gunners stood watch for enemy aircraft. Chief Machinist Mate Robert Patterson, who supervised the Enterprise's elevator repairs, later described the complexity of the work. We essentially built a new elevator system from raw steel. We cast the gears, machined the reduction units, rewound the motors. Everything except the basic steel structure was manufactured aboard Vulcan using tools and equipment we carried with us. By early 1943, the Japanese Naval General Staff began receiving intelligence reports that fundamentally challenged their assumptions about American repair capabilities. Submarine reconnaissance and prisoner interrogations revealed that American ships were returning to combat far sooner than Japanese calculations had predicted. Vice Admiral Chuichi Nagumo, hero of Pearl Harbor, reviewed these reports with growing concern. A damaged American cruiser observed at Espiritu Santo had returned to combat in just 3 weeks. A destroyer, with her bow blown off, reappeared in 2 weeks with what appeared to be an entirely new forward section. Even more troubling were the carriers. Vessels that should have required months of repairs were returning to action in mere weeks. Traditional intelligence analysis couldn't explain these unexpected recoveries. The breakthrough came when Lieutenant Commander Yahachi Tonabe, commanding submarine I-168, observed something extraordinary while on reconnaissance near Espiritu Santo in March 1943. Through his periscope, he saw the damaged USS New Orleans, which had lost its entire bow to a Japanese torpedo at Tasabaranga, being rebuilt by what appeared to be a floating factory. Tanabe's detailed report described the USS Vestal, a floating machine shop specifically designed for heavy cruiser repairs. Vestal's crews were manufacturing an entirely new bow section for the New Orleans, complete with rebuilt compartments, weapons mounts, and crew facilities. The work was proceeding with industrial precision and speed, far beyond what the Japanese had expected. The ship didn't appear to be merely undergoing repairs. It was being rebuilt. Tanabe reported multiple cranes working simultaneously and welding taking place on 3 levels. His report reached Admiral Yamamoto's headquarters within days, forcing a reassessment of American capabilities. The USS Vestal represented the next stage in the evolution of floating machine shop technology. Originally designed as a collier, Vestal had been retrofitted to serve as a mobile shipyard, and her crew demonstrated the full scope of what these floating factories could achieve. Converted into what was effectively a complete naval shipyard capable of independent operation, the USS Vestal became a mobile manufacturing powerhouse. Her machine shops could fabricate everything from propeller shafts to gun mounts. Her electrical shops had the ability to rewire an entire cruiser. Her foundries were capable of casting replacement armor plating. Most impressively, Vestal carried the templates and technical drawings needed to rebuild major warships without relying on shore-based engineering departments. Her technical library contained detailed construction plans for every major class of American warship. Her metallurgy laboratory could analyze damaged components and determine the proper replacement materials. In essence, Vestal was a floating repository of American naval engineering knowledge. The psychological impact on Japanese naval personnel who witnessed these capabilities was profound. Commander Mitsu Fuida, who had led the attack on Pearl Harbor, encountered American floating machine shop operations during his recovery from injuries sustained at Midway. His memoir describes watching these repair operations at an undisclosed location in late 1943. I observed the enemy repairing battle damage with methods and speed that seemed impossible, Fuida wrote. A destroyer, whose entire superstructure had been destroyed, was being rebuilt with entirely new construction. The Americans were not merely repairing their ships, they were improving them during the repair process. Each damaged vessel returned to combat stronger than before. This observation highlighted a crucial advantage of American floating machine shop operations. Unlike traditional emergency repairs that simply restored minimal functionality, these floating shops performed complete reconstructions that often enhanced the original designs. Damaged radar systems were replaced with upgraded models. War machinery was rebuilt to higher specifications. Battle damage became an opportunity for enhancement rather than mere restoration. By mid-1943, American floating machine shops had established a network of mobile industrial capabilities across the Pacific. The USS Vulcan operated in the Southwest Pacific, supporting operations from Guadalcanal to the Philippines. The USS Vestal served the Central Pacific Campaign, moving from base to base as operations advanced. The USS Ajax specialized in submarine repairs, while the USS Hector focused on maintaining destroyers and escort vessels. Each floating machine shop was the equivalent of a major shore-based facility, with several crucial advantages. They could relocate as operations progressed, ensuring proximity to combat zones. They were immune to land-based attacks, operating in anchorages protected by the fleet they served. Most importantly, they brought American industrial capability directly to the front lines where it was needed most. The Japanese response reflected their growing recognition of the strategic importance of these vessels. Starting in late 1943, Japanese submarines received orders to prioritize attacking floating machine shops instead of combat vessels. The reasoning behind this was strategic. Sinking a floating machine shop would eliminate repair capabilities, which was seen as equivalent to destroying multiple warships. However, these attacks largely failed due to the robust defensive screens that protected the floating machine shops. The USS Vulcan survived 17 submarine attacks between 1943 and 1945. Her defensive armament, including multiple 5-inch guns and numerous anti-aircraft weapons, combined with escort destroyer screens, created nearly impenetrable protection. The few successful attacks confirmed that the Japanese had recognized the importance of these vessels. When the submarine I-26 damaged the USS Vestal with a torpedo hit in January 1944, the American response was swift and overwhelming. Every available vessel joined the hunt for I-26, which was eventually destroyed with all hands. the protection of floating machine shops became a priority for the fleet. As American forces advanced across the Central Pacific in 1944, floating machine shops enabled an operational tempo that Japanese defenders could not counter. The rapid capture and development of island bases was supported by floating machine shops that arrived with the invasion fleets, ready to begin major repairs immediately upon securing anchorages. At Majuro, the USS Ajax arrived with the invasion fleet and quickly began overhauling destroyers damaged in previous operations. At Anatahan, the USS Hector established complete submarine repair facilities within days of the island's capture. These rapid deployments meant that advancing American forces could maintain full operational capability without the delays traditionally associated with establishing shore-based facilities. The strategic impact was massive. Instead of damaged vessels having to sail to Pearl Harbor or the West Coast for repairs, which would take months, they could be fully restored within the combat zone in just weeks. This effectively tripled or quadrupled the operational availability of the American fleet, creating a mathematical advantage that Japanese forces could not overcome through tactical excellence alone. Admiral Chester W. Nimitz recognized the strategic revolution that floating machine shops represented. In a directive to all Pacific Fleet commanders dated July 15, 1944, Nimitz wrote, "Floating machine shops. Floating machine shops have fundamentally altered the balance of power in the Pacific. Our ability to maintain full operational capability within the combat zone offers a decisive advantage that must be fully protected and exploited." The Japanese recognition of this strategic shift is reflected in their changing tactical priorities. By late 1944, Japanese battle plans began to specifically target American auxiliary vessels, particularly floating machine shops. The urgency behind these orders highlighted Japan's realization that conventional attacks on combat vessels could no longer yield decisive results when those vessels could be quickly restored to full combat readiness. Captain Riki Hai Inaguchi, senior staff officer to Admiral Takajiro Nishi, the creator of the Kamikaze Corps, provided post-war testimony about Japan's growing awareness of American floating machine shop capabilities. "We calculated that successful kamikaze attacks would remove American carriers from combat for months," Inaguchi stated. "Instead, we observed these same carriers returning to battle within weeks, often with enhanced capabilities. The enemy's floating repair facilities had rendered our entire strategic calculation invalid." The impact of floating machine shops extended far beyond repairs. They acted as technological transfer hubs, delivering the latest American industrial innovations directly to the combat zones. New radar systems, improved aircraft engines, and upgraded weapon systems were reaching the fleet months ahead of their normal arrival through traditional supply channels. The post-war technical reports of the USS Vulcan reveal the scope of this technological advancement. Between 1943 and 1945, Vulcan shops produced over 12,000 major components, from aircraft engines to gun barrel assemblies. Her metallurgy laboratory developed advanced alloys specifically designed for Pacific operations. Her electrical shops created enhanced radar systems optimized for tropical conditions. This kind of innovation under combat conditions was unprecedented in naval history. Traditionally, naval operations separated research and development from deployment by months or even years. Floating machine shops collapsed this timeline, enabling the immediate implementation of technological advancements based on real-time combat feedback. The encounter of Japanese naval aviation with constantly improving American aircraft highlighted this challenge. Japanese pilots reported that American fighters seemed to improve in performance between engagements. What they were observing was a real-time modification of aircraft based on the combat damage assessments made aboard floating machine shops. A specific example of this can be seen with the Vulcan's aircraft engine shop. After analyzing battle damage to F-6F Hellcat engines, Vulcan's engineers developed improved cooling systems that increased engine reliability in tropical conditions. These modifications were quickly implemented on dozens of aircraft within days of development, giving American pilots an immediate advantage in subsequent battles. By 1945, the network of floating machine shops had essentially created a mobile industrial base that moved with the advancing fleet. As American forces prepared for the invasion of Japan, floating machine shops positioned themselves to support operations in Japanese home waters, bringing American industrial strength right to the doorstep of Japan. The most devastating demonstration of floating machine shop capabilities came during the carrier raids on the Japanese home islands in February 1945. Task Force 58, commanded by Vice Admiral Mark Mitchell, launched massive strikes against aircraft factories and naval installations around Tokyo. Japanese kamikaze counterattacks inflicted significant damage on several American carriers, including the USS Saratoga and the USS Franklin. Under traditional naval doctrine, these heavily damaged carriers would have been forced to withdraw to Pearl Harbor or the West Coast for months of repairs. Instead, they sailed to WWII Atoll, where the most sophisticated floating machine shop operation of the war was waiting for them. What the Japanese observed that would completely shatter their remaining illusions about American industrial capabilities. The USS Vulcan had been joined by 3 additional floating machine shops, USS Ajax, USS Hector, and the newly arrived USS Prometheus. Together, they represented more manufacturing power than some entire nations. The technical specifications of this floating industrial complex were staggering: 47 major machine tools, 6 foundries, electrical shops capable of rewinding motors weighing 20 tons, and metallurgy laboratories able to analyze and duplicate any known alloy. In March 1945, Captain Minoru Yokoi, commanding the submarine I-401, managed to penetrate WWII's defenses. His periscope observations, transmitted to Tokyo before his submarine was detected and destroyed, provided the Japanese with their first detailed assessment of American floating machine shop operations. Yokoi's final transmission read, "Multiple large vessels conducting industrial operations on damaged carriers. Observe complete reconstruction of flight deck sections. Enemy possesses mobile shipyards." The USS Franklin presented the ultimate test of floating machine shop capabilities. Hit by 2 500-pound bombs during strikes on Kyushu on March 19, 1945, Franklin suffered the most severe damage of any American carrier to survive the war. 77 sailors were killed or missing, her flight deck was gutted, and her hangar deck became a twisted mass of metal. By traditional standards, Franklin was a total loss. However, the USS Prometheus, the most advanced floating machine shop ever built, took on the daunting task of rebuilding her from a waterline up. Prometheus displaced 21,000 tons and carried a crew of 1,800 specialists. Her machine shops were equipped with lathes capable of turning propeller shafts, presses that could reshape, aircraft carrier deck plating, and electrical facilities that could rewire an entire ship systems. Master Chief Petty Officer William Hennessy, who supervised the reconstruction of Franklin, later testified before Congress about the scope of the work. "We essentially built a new carrier inside the hull of the old one. New flight deck, new elevators, new electrical systems, new machinery spaces. Everything except the basic hull structure was manufactured aboard Prometheus using materials and equipment we carried with us." The rebuilding of Franklin took 11 weeks, an extraordinary timeline that would have tested the capacity of major shore-based facilities with unlimited resources. Prometheus accomplished this feat while anchored in an open lagoon, maintaining constant anti-aircraft watches and simultaneously supporting repair operations on dozens of other vessels. The technical achievement represented something unprecedented in naval history. Japanese intelligence officers analyzing reconnaissance photographs of WWII could hardly believe their eyes. The carrier, which had entered the anchorage as a smoking wreck, emerged 11 weeks later with obvious improvements over her original design. New radar systems, upgraded anti-aircraft armament, and enhanced aircraft handling equipment made the rebuilt Franklin superior to a pre-battle configuration. Admiral Sejima Toyota, Commander-in-Chief of the Combined Fleet, received these intelligence reports understanding that Japan was now facing something far beyond conventional military opposition. His staff analysis, preserved in captured documents, concluded, "The enemy's floating repair capabilities represent industrial organization on a scale that cannot be countered through conventional naval operations. They have brought their homeland's manufacturing capacity to our waters." The strategic implications of this shift went beyond individual ship repairs. Floating machine shops enabled American forces to maintain an operational tempo that Japanese defenders found impossible to match. During the Okinawa Campaign, which began on April 1, 1945, American naval forces absorbed unprecedented kamikaze attacks while maintaining full operational capability through continuous floating machine shop support. The USS Bunker Hill, hit by 2 kamikaze aircraft on May 11th, suffered damage that would normally have required 6 months of shore-based repairs. Instead, Prometheus restored her to full operational status in just 4 weeks while anchored off Kurumato. The USS Enterprise, damaged by a kamikaze attack on May 14th, was repaired and returned to combat in just 3 weeks. The overwhelming mathematical advantage this gave the Americans was clear. Captain Riki Hai Inaguchi, analyzing the effectiveness of kamikaze attacks for Admiral Onishi, calculated that successful attacks on American carriers removed them from combat for an average of 21 days, rather than the projected 6 months. Our entire strategic concept was based on cumulative damage overwhelming American repair capabilities, Inaguchi wrote in his post-war analysis. The enemy's floating machine shops made our calculations meaningless. The technical sophistication of floating machine shop operations exceeded anything in Japanese experience. The USS Vulcan's metallurgy laboratory developed specialized alloys for Pacific operations, including corrosion-resistant steel that performed better than original specifications. Her electrical shops designed radar systems optimized for tropical conditions, while her machine shops manufactured precision components with tolerances measured in thousandths of an inch. Chief metallurgist Dr. Robert Steinberg, serving aboard Prometheus, described the innovation process. We weren't just repairing battle damage. We were continuously improving American naval technology based on combat experience. Every repair incorporated lessons learned from previous engagements. Our ships returned to battle better than they had left. This real-time technological development provided a decisive advantage that Japanese forces could not match. Their repair facilities, concentrated in the home islands, were increasingly isolated from combat zones by American submarine warfare and air attacks. Japanese ships damaged in battle now faced month-long voyages to reach repair facilities that lacked the advanced equipment and specialized materials available aboard American floating machine shops. The contrast in repair philosophies reflected deeper cultural and industrial differences. Japanese naval tradition emphasized spiritual resilience and making do with available resources. Battle damage was accepted as inevitable and something to endure. Repairs in Japanese naval tradition focus on restoring minimal functionality rather than enhancing the damaged vessel. In contrast, American industrial culture approached battle damage as an engineering challenge to be solved with superior technology and organization. The USS Ajax exemplified this difference during her work on the battleship USS Pennsylvania, which was damaged by a torpedo attack during the Okinawa campaign. Instead of simply patching the torpedo hole, Ajax's engineers completely redesigned Pennsylvania's underwater protection system, incorporating lessons learned from previous torpedo attacks. The rebuilt battleship emerged with enhanced survivability against submarine strikes. Throughout 1945, the scale of floating machine shop operations grew continuously. By the war's end, 7 major floating machine shops were operating across the Pacific, supported by dozens of smaller repair vessels and tenders. Their combined manufacturing capacity surpassed that of many pre-war shipbuilding nations. These shops performed over 3,000 major repairs and manufactured more than 40,000 precision components. Japanese naval intelligence made multiple attempts to target floating machine shops, recognizing their strategic importance. Special submarine squadrons were tasked with attacking these vessels over combat ships, as destroying one floating machine shop eliminated repair capabilities equivalent to sinking multiple warships. These attacks, however, generally failed due to the formidable defensive screen protecting the floating machine shops. When the submarine I-58 managed to torpedo the USS Indianapolis in July 1945, the immediate American response focused on protecting the floating machine shops rather than hunting the submarine. Every available destroyer was deployed to screen the USS Vulcan and USS Prometheus, signaling that floating machine shops had become more strategically valuable than individual combat vessels. The psychological impact on Japanese naval personnel of witnessing American floating machine shop capabilities was profound and demoralizing. Commander Mitsu Fuida, in his post-war memoir, described the effect on Japanese morale. We realized we were fighting not just the American Navy, but the entire American industrial system made portable. Every damaged American ship would return stronger than before, while our damaged vessels often never returned at all. This sense of demoralization extended to the highest levels of Japanese command. Admiral Toyota's final strategic assessment, written in July 1945, acknowledged the hopelessness of Japan's position. The enemy's floating machine shops have made time and distance irrelevant. They repair ships faster than we can damage them. They bring their industrial superiority directly to our waters. Continuation of hostilities serves no strategic purpose. The technical achievements of floating machine shops during the Pacific War established principles that would shape naval operations for decades. The ability to maintain complex weapon systems far from industrial bases, the integration of combat and support functions, and the real-time implementation of technological improvements all became standard features of modern naval operations. Master Chief Petty Officer Thomas Rodriguez, who served aboard 3 different floating machine shops during the war, captured their significance in his memoir. We weren't just fixing ships. We were proving that American industry could go anywhere and do anything. Every repair was a demonstration that distance and geography meant nothing when you had the right tools and the right people. The Japanese recognition of floating machine shop capabilities and their decisive impact is evident in Emperor Hirohito's surrender announcement on August 15, 1945. While the atomic bombs provided the immediate catalyst for surrender, the Emperor's reference to the war situation having developed not necessarily to Japan's advantage also encompassed the cumulative effect of American industrial superiority, with floating machine shops being a prime example. Admiral Toyota's post-war interrogation revealed the most direct Japanese assessment of the floating machine shop impact. Your floating machine shops defeated us as surely as your submarines and aircraft. We could damage your fleet, but you could repair it faster than we could attack it. You brought your entire industrial system to our waters. Against such capability, traditional naval warfare became obsolete. The legacy of World War II floating machine shops extends far beyond their immediate wartime impact. They demonstrated that industrial capacity could be made mobile and projected across vast distances. Modern naval operations continue to rely on the mobile repair and manufacturing capabilities developed during the Pacific War. The principles pioneered by ships like the USS Vulcan and USS Prometheus remain central to naval logistics today. The story of Japanese encounters with American floating machine shops represents one of the most decisive yet underappreciated factors in the Pacific War's outcome. While battles and campaigns receive historical attention, the quiet work of floating machine shops, rebuilding damaged vessels, improving technology, and maintaining operational tempo, proved equally decisive in determining the war's outcome. For Japanese naval officers who witnessed these capabilities, floating machine shops represented something beyond conventional military opposition. They embodied American industrial civilization made mobile, bringing manufacturing capability directly to the point of conflict. Against such industrial might, traditional military virtues alone could not prevail. The Pacific War became a contest not just of fleets and air forces, but of industrial systems. In that contest, America's floating machine shops provided the decisive advantage. Thank you for watching. For more detailed historical breakdown,